Hey, talking about math industry, and we are going to take a look at converging and diverging series. So in the past, we've looked a lot about summations and series, and this one is a formula that we've recognized in the past, the geometric series formula, where the sum is going to equal the first term of the sequence, then you have 1 minus the ratio as n as the number of terms as the exponent, and divide that by 1 minus the common ratio. But there is a pattern that I think is very, very satisfying that you might want to think about, because doing this is great, but seeing the pattern can be more satisfying. So we have a converging series and a diverging series. Let's start with the converging one. So notice a pattern right here. Here is the first one we did, and when you do this and complete all that, you get an answer of 8.715. Pay attention to the 8 and the 715 right there. If you try it with the same thing, where S of n is 30, do all the math, you get 8 and 998. But there's a decimal, so 8.998. The mathematics with here and here is the same thing as using the geometric series formula. This basically means you put all the numbers in here, while the sigma notation is sort of a representation of what's happening. But here's the catch. You increase the 75, again, you get 8.99999. So there is a pattern that's happening that is very, very satisfying. The number that increases from 12, 30, and 75 is converging to some kind of number where it tries to reach the number 9, but it will never, ever, ever reach the number 9. And here is another part that's really, really cool. If you take a look at the fractions in the sigma notations, you will notice that the fraction, the numerator, is always going to be smaller than the value of the denominator. So we can say that if the finishing touch, or the end, is increasing, and then we can say that the numerator is going to be less than the denominator, then we can say that there's a limit to some kind of whole number that the converging series is trying to get to, but it will never, ever, 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 ever get there. So that is converging. But what about the diverging series? So when it comes with the diverging series, we can say that it's opposite from converging. Here's the reason why. You have a 12 and you have a 1 in the sigma notation. When you do all of this and complete it, you get a massive number of 2,291.97. If you do the Sn of 30, which is highly reflected off that geometric series formula, the one right over here, then it's going to be, I'm not going to say it, but this crazy long number. But if you do it to 75 in sigma notations, all these are done the same way. You get this 2.17 times 10 to the power of 17. What? Who knows what's going to happen? So this one, the diverging one, is very, very chaotic, because every time you increase the number of where you finish the series, you get a drastically gigantic number in the end game. But wait, how is this different than converging, besides the movement? Well, we know already that converging means that every time you get closer to a whole number, it converges into a smaller difference. But if you take a look at diverging, that difference is starting to get a lot bigger and bigger and bigger. But here's the catch. Notice from converging, you have the numerator smaller than the denominator. And this one is also the numerator smaller than the denominator. But right over here, notice how the numerator is larger than the denominator, which means it's known as an improper fraction. And when you have an improper fraction, we can say and know that it's greater than 1. So that means that if there's something that's greater than 1, that means not only you're adding with the sigma notation, but you're creating a lot bigger gap to get a much bigger answer. So that logically explains why this is a diverging series. So yeah, I hope this video has helped you understand this idea, but converging and diverging series. Thank you for watching California Airlines Math Industry. Like and subscribe.